In this video, we will solve a system of linear equations using any method. We have the equation, the quantity x minus 1 divided by 9, plus the quantity y plus 2 divided by 3 equals 4. Then our second equation is the quantity x minus 1 divided by 3 minus the quantity y plus 2 divided by 12 equals 25. We first need to rewrite this system with equations that do not have fractions. We can multiply the first equation through by the least common denominator of 9, and the second equation will multiply through by the LCD of 12. So notice that 9 times x minus 1 over 9 just gives us x minus 1, plus the 9 times y plus 2 divided by 3 gives us 3 times y plus 2, and then is equal to 9 times 4, or 36. The second equation, when we distribute by 12, 12 times x minus 1 divided by 3. Note that the 3 goes into 12 4 times, so we have 4 times x minus 1 minus 12 times y plus 2 over 12. Well, the 12s divide out, but really we have a minus 1 times y plus 2 in parentheses. And then it's equal to 12 times 25, which is 300. So we'll go through one more step to simplify these to get rid of the grouping symbols. So our system is equivalent to x minus 1 plus 3y plus 6 equals 36. And the second equation is 4x minus 4 minus y minus 2 equals 300. Be careful about the distributing. So then we need to rewrite each equation in standard form, which is that ax plus by equals c. And when we do that, notice that the x minus 1 plus 3y plus 6 equals 36 is equivalent to x plus 3y equals 31. Right, because a negative 1 plus 6 is 5, and then we would subtract 5 from each side. The second equation is 4x minus y is equal to 306. Again, notice that the negative 4 minus 2 is negative 6, but we add 6 to each side. So now we have this system, x plus 3y equals 31, and 4x minus y equals 306. This system is set up to use the addition method or elimination method to solve. And remember, in doing that, we want to create a system so that we can add the equations and eliminate one of the variables. And to do that, the coefficients of one of those variables has to be opposite. We could choose to eliminate either, it doesn't really matter. But if we rewrite the system so that we multiply the second equation by 3, notice that the 3y from the first equation and then negative 3y from the second add to 0. So we're going to multiply the second equation by 3, which leaves the first equation unchanged. So we still have x plus 3y equals 31. The second equation becomes 12x minus 3y is equal to, now 3 times 306 is 918. Now that we have opposites as coefficients, we add the equations in the system to get x plus 12x, which is 13x, equals 31 plus 918 is 949. Then we divide each side by 13. So x is equal to 73. Now, to solve for y, we can replace x in one of those equations with 73. to figure out what y is equal to. So if we let x be 73 in this first equation, we would have 73 plus 3y equals 31. Subtract 73 from each side. So 3y is equal to negative 42. And then divide by 3. And y is equal to negative 14. So the solution of the system is the ordered pair 73, negative 14. If we're asked to write that in solution set notation, we put that ordered pair in the set brackets.